Hello and welcome friends. In this particular module, we wish to get introduced with some basic concepts of remote sensing. We'll discuss about definition and principle of remote sensing, various stages, history, types and advantages of remote sensing. Here, as you learn the content, you will be able to define remote sensing and will also be able to explain principle, stages and types of remote sensing. This is basic definition of remote sensing. The technique of acquiring information about an object by recording device that is not in physical contact with the object by measuring portion of reflected or emitted electromagnetic radiations from the object under consideration. Human eye is an excellent example of remote sensing. In fact, sight, smell, hear are rudimentary examples of remote sensing. We see certain object, not necessarily that object being touched. We sense the fragrance, we listen something. In all these particular human organ sensations, the entity under consideration is not being touched. However, information associated with that entity is being received. Let's try to understand the basic principle of remote sensing. As you see here in the right sketch, there is one energy source. The radiations obtained from that energy source are reaching various entities. These entities, as they receive that particular energy, further they reflect back that energy towards some sensor, and that sensor tells us about the information based on some specific entity termed as spectral signature. A spectral signature of an object or even the ground surface feature is set of values for the reflectance or radiance of the feature, each value corresponding to the reflectance or the radiance arranged over a different and well-defined wavelength interval. In simple words, every object has got some unique property. It could be depending on its structural aspect, chemical or physical property, its roughness, the angle at which that energy is being received, with what intensity that energy is reaching to the surface, as well as the wavelength of that radiant energy. Each object has got unique structure, it has got unique capability to receive the energy. The energy being received will be transmitted, reflected, or absorbed, and this is unique property of that particular object, which is the spectral signature of that feature. In order to understand this particular concept and associated information, there is a need of involvement of lot many agencies together. So the remote sensing as a technique is involving the knowledge of the optics, spectroscopy, photography, computer science, as well as electronics and even the telecommunication, satellite technology, and all the associated processing and user sector. So all such agencies and associated technologies are integrated together in order to act under the umbrella of remote sensing. Let's try to go further in depth now. So this energy source could be sun, or there could be self-emission. As the energy is emitted from this energy source, it propagates through the atmosphere. The atmosphere is again consists of lot many things. There is presence of variety of the gases. There is a presence of particles, some ambient as well as even pollutants. So each of such constituents has got again some specific property. So depending on that particular property, the material which is receiving that particular energy will cause the absorption of some of the energy, scattering of some of the energy, as well even the transmission of that energy and reflection of that energy. As we discussed on the earlier slide, each of such materials which are receiving the energy and having the interaction with the electromagnetic radiations in the form of energy have some specific digital signature, spectral signature. Accordingly, as that energy is reflected back, it would be received by variety of the platforms and sensors, as they are called, which could be ground bore, or that could be situated at the high altitudes, or even they could be airborne in the form of balloons, helicopters, planes, or even some satellites. These platforms send that information to antennas situated over the ground. The data transformed would be processed by various agencies, and certain data products would be developed. These particular data products are refinements of the raw information that is received through the antenna. These products will be further processed as well as even interpreted, and further products will be developed for the information of all the user sector. User sector at the variety of the levels will be using that for understanding, analyzing, in addition to the decision making. These stages that we discussed through the sketch are mentioned here in the form of stages in remote sensing. Let's try to understand what is the history of the remote sensing. As we travel back to 1794, certain military operations had employed certain balloons in order to understand the military importance of certain features through the reconnaissance conducted by using these balloon-like techniques remotely. Even in 1840, certain balloonists in Europe took the pictures of the ground for civil applications by making use of photocouplable camera. In 1907, certain German scientists had employed the fleet of pigeons. The way you see here, these pigeons are strapped with some cameras on their front. So they were taught to fly on the requisite portion and hence to have the photographs of the region of the interest, which were further interpreted according to the scope of the interest. In 1906, the photographs of the San Francisco earthquake were obtained from a kite. In the First World War, remote sensing and aerial photography became an important reconnaissance tool. So here, as you see, certain aerial photograph is taken in order to understand the infrastructure of roads, buildings, and such kind of information could have been used in order to define the defense strategy. In World War II, the technique of aerial photography became a key militaristic asset and photo recognition became highly valuable skill. According to the records, the first non-military satellite was imaged in 1960s in order to monitor the weather patterns. This 1970 onwards, the technology began to evolve very quickly through the mid-1980s with multiple types of satellite sensors being launched as well as through the commercialization of software like geographical information system. Today, Lot many countries have their own satellites which are orbiting around the earth for variety of the purposes and have been sending the information continuously. As we move ahead through the presentations, we will learn more about it. Let's try to understand how the technique of remote sensing is classified. It can be classified based on the source of the energy as passive remote sensing system or active remote sensing system. This passive remote sensing system make use of the naturally available energy which is in the form of sun by interpreting the reflections and the absorptions. Whereas these active energy systems are providing their own source of energy for the illumination of the objects that are under consideration. While discussing the concept of electronic distance measurement, we got acquainted with the electromagnetic spectrum. So as we know, only certain portion of that particular electromagnetic spectrum is employed for the refined operations of distance measurement. In the continuation, this remote sensing can also be classified based on the range of the portion that is employed in order to sense the objects remotely. So, optical remote sensing, thermal remote sensing, and microwave remote sensing are the three classes based on the portion of electromagnetic spectrum. Optical remote sensing use visible, near infrared and mid infrared and that are associated with the wavelength of 0.3 micrometer to 3 micrometer. Thermal remote sensing systems are based on the emitted radiations having the length of 3 to 5 micron and 8 to 16 microns. Whereas microwave remote sensing systems use higher wavelength having 1 mm to 1 meter. In view of surveying, this technique has got lot many advantages. Firstly, it gives the synoptic view of the features under consideration. So, this facilitates the study of various features situated on the ground in their spatial interrelationship. It also helps to delineate the required feature and now the term phenomenon. As we discussed about the basic principles of surveying, we understood that surveying is an art of determining relative positions of the various points on, above and beneath the surface of the earth. And the basic purpose of surveying operations was to prepare, plan or map. Now as you see here, as we discussed about the energy source and propagation of electromagnetic wave through the atmosphere and reaching to the features that are situated on the Earth's surface. The propagation and the interaction with the various constituents of the atmosphere will be depicting some information. That could be existing pollution level, the presence of the particulate, or the change in the humidity, moisture, and even certain meteorological conditions. As such, By employing this remote sensing technique, we are not simply interested in understanding the scope and footprint of some feature on above and beneath the surface of the earth, but we can discuss something about the phenomenon associated with that earth's surface. Accessibility is the next advantage. With this technique, it is possible to gather the information about the area when the ground surface is not accessible for the surveyor. So that may be some hazardous area, that could be mountainous area, or through certain, say, oblique techniques, one may catch some of the features which are not even situated in the ethical limits, ethical boundaries of a particular nation. This particular information is gathered quickly, it saves the time, it saves the cost, and the most importantly, there are variety of applications for almost all different disciplines like geology, forestry, land use, agriculture, defense, urban planning, fisheries, and all the civil engineering related structures, just for example. Let's try to understand some of the case study to know how the technique is employed. This certain image is of Great Salt Lake obtained by Landsat in 1985. It is depicting certain features. One dominant is its footprint. Another, the sources of the water, maybe water runoff, maybe melting of snow, and we can also see here certain adjacent patterns. These land patterns are telling us about the habitat, wild habitat, and so many things could also be associated with the biodiversity. As we compare the image of the same feature taken in 2010, there is a considerable reduction in the footprint. There is a reduction in the incoming water. Some of the portions are totally removed because of some or other reasons. There is an encroachment of these wetlands over these particular water bodies and so many such things. So, if we consider this comparison of the images, one can interpret it according to the requirement depending on one's interest. So, if similar images are caught for certain region, we can understand what is the change in the land patterns, what is the trend of the people to move around, how the infrastructure is growing, and lot many similar aspects. Here also you can see these are the two images of a same region taken between the span of this 1999 2001. So the change in the vegetation pattern, the change in the flooding patterns, and certain hydrological changes can be easily seen. Here the deposition of the debris and hence the development of the new currents, the change in the color patterns are giving us the information associated with all the features that are covered over these two photographs by making use of remote sensing technique. So thanks for your attention. I hope the discussion that we had has helped you to understand some basic concepts of remote sensing. So as we move ahead, we'll discuss about the concept of energy interaction that we just got introduced in the form of reception, absorption, transmission to further depth in the context of remote sensing. So bye till then, I wish you very happy learning. Thank you.